Hello, calculus. Hope everyone is having a fantastic day today. A couple of things that I want to go over before we get into what we're going to do for this lesson. I actually need to correct your notes. Again, I told you to do this in class today, but if for some reason you weren't there, then you'll need this. On the notes for 27, these are the derivatives of trig values. I actually got two of these backwards. The derivative of cotangent and the derivative of cosecant need to be switched around. And I'm sorry about that. I sat there and I wrote them down, and since we didn't do an example with them, I didn't notice that they were wrong. So this is negative cosecant squared x, and the derivative of cosecant here ding, is negative cosecant x cotangent x. Again, I apologize about that. I should have noticed that those were off, but well, nothing like correcting them now. Okay, so before we get into this lesson, there's a few things you're going to need. You'll need these formulas for your derivatives of your trig functions. You also need a unit circle handy. Okay, so before we get into that lesson, make sure that you have both of those things available. Okie doke. Now today we're going to be talking about tangent lines of trig functions. Now you already know what a tangent line is. You know how to find it. You know that there are two things you need. You need a point and you need a slope. The point comes from plugging this x into this equation. The slope comes from plugging this point into the derivative. Simple enough, right? So let's actually figure out what these things are going to look like here. I've got an equation here. Y is cotangent of x minus 2 cosecant of x. And to find your points, so let me just write a few things down here. Your point is going to come from pi over 3 comma f of pi over 3. Okay? So let's figure out what f of pi over 3 is. I'm going to set this thing up and plug it in here, so it's going to be cotangent of pi over 3 minus 2 cosecant of pi over 3 Okay. Now, if you'll remember, cotangent and cosecant are called reciprocal functions. Let me write these down up here for you. Actually, you know what? I have them written down already. If you would, pause this really quickly and get these down. You have sine is your y value over your r value, but on the unit circle, it's always going to be 1 for r. On cosine, it's x over r. Tangent is y over x. Again, so your sine and cosine are just your y and your x value because r is 1 here. And then to find cosecant, you flip sine. To find secant, you flip cosine. So if I need to find cosecant of pi over 3, so I'm going to go to pi over 3, look at my y value, and flip it. So pause those, get them down really quickly. So back to here. So I'm still finding f of pi over 3. So I'm going to go to pi over 3 on my unit circle, which is right here. I'm going to look at my y value. This is going to be for cosecant, and I'm going to flip that. So let me get to that in just a second. Let's do cotangent first. Cotangent is x over y, 1/2 over square root of 3 over 2. Now if you actually had that written down, it'd be 1/2 over square root of 3 over 2. Your 2's would cancel. And then you can simplify it a little bit later with multiplying the square root of 3. Let's save that till the last step just for kicks and giggles. So it's going to be 1 over the square root of 3 minus 2, and your cosecant value, I go to my y, which is my sine, and I flip it. 2 over the square root of 3. If you're a little lacking on the trig skills, make sure you let me know. That way we can address it before it kind of gets out of hand. Okay, so let's set this thing up here. This is going to be 1 over the square root of 3 minus 4 over the square root of 3, which is negative 3 over the square root of 3, multiplied by the square root of 3 in the top and bottom to rationalize the denominator. And you'll get negative 3 square root of 3 over 3, which is just negative square root of 3. So your point is going to be pi over 3, comma, negative square root of 3. Okay? Again, your point is pi over 3, comma, negative square root of 3. Next step's a slope. Schlop. So to find a schlop, we're gonna go ahead and take the derivative of y. Let's call it let's call this thing the derivative here. We've already got y listed up top, so we don't need to list it again. So I'm gonna go to my trig rules. Look at cotangent x. Cotangent x, and the derivative of cotangent x is negative cosecant squared x, and then it's minus, and remember we have a negative 2 here already, so let's go ahead and put that 2, and it's going to be times the derivative of cosecant x. Now the derivative of cosecant x, from looking at 27 over at my derivative notes here, is going to be negative cosecant x cotangent x. So just to simplify that a tick, it's y prime is negative cosecant squared x plus 2 cosecant x cotan x. Okay? Alright, so from here I need to find my slope. Now again, back up at the top. To find your point, plug this x into your equation. To find the slope, plug this x into your derivative. So let's come down here, and let's say that this is, we're going to be plugging into our slope here, we're going to be plugging in the x value of pi over 3, so this will be negative cosecant squared pi over 3. That means I'm going to find this, whatever this value is, and square it, plus 2 cosecant pi over 3. Oh, I guess I don't need that. Cotangent of pi over 3. Alright. Now we already have a lot of these values from up top. Remember the cosecant of pi over 3 from up here. Here we go. Cosecant of pi over 3 was 2 square root of 3, 2 over the square root of 3. So this would be negative 2 over the square root of 3 squared plus 2 times the cosecant of pi over 3, which is 2 over the square root of 3, times the cotangent of pi over 3, which is 1 over the square root of 3. Again, I'm getting those from the unit circle, just bringing those down from the top here since I've already found them. And then let's simplify. This will be 2 squared, square root of 3 squared, so that's going to be a negative 4 over 3 plus, and we've got 2 times 1 is going to be 4 on the top, over the square root of 3 times the square root of 3 is 3 on the bottom. Negative 4/3 plus 4/3 is 0. Hey! Our tangent is 0? Or our slope of the tangent line is 0? What? So the tangent line then is going to be y, and we've got a couple of things that we're going to do here. Remember that we're using the points from up here, right? This guy here. So we've got the tangent is y plus the square root of 3 is equal to 0 times x minus pi over 3. Point, slope, plug them in. Or you could just say, since this is all going to go to 0 anyway, you can move your square root of 3 over. It could just be y is the negative square root of 3. And that's okay too. Okay. So then that actually brings up an interesting question, because we've never had a tangent line that was horizontal. Or we've never come up with a normal line to a tangent line that's horizontal. Okay, so because we've got a slope of 0 here, your normal line, if your tangent line is a horizontal line, what kind of line would your normal line be? What's perpendicular to a horizontal line? Well, it's a vertical line, right? Okay, so a vertical line, think about this here. You've got y is the negative square root of 3, so it's this guy here. And the point we're using is pi over 3. Well, what would the equation for this line be? That would be just x equals pi over 3. Okay, that's all she wrote. So the only difference here is that we're finding we're using trig values. Really, that's the only difference. Everything else is just built from that. All right. On the back here, I'm trying to keep this a little bit shorter. It says, write the equation of the tangent line and the normal line to this equation at this point. Oh good, they've already given me a point, so they're saving me some work here. So I need to find f prime of x. Now this is going to be a product rule, right? So it's the first times the derivative of the second. The derivative of sine is cosine, and then plus the derivative of cosine is negative sine, plus the second, sine x plus cosine x, times the derivative of the first. And the derivative, again, the derivative of sine is cosine of x. First d second plus second d first. Okay, let's simplify. F prime of x, distribute, and you have sine x cosine x. This is negative sine, so you've got a sine times a negative sine is going to be negative sine squared x, plus sine x and cosine x, times cosine would be sine cosine, sine x cosine x, plus cosine squared x. Okay. Alright, now I'm trying to find a derivative at a point. Now you can actually simplify this a little bit farther even. If you wanted to, you can bring your sine x and your cosine x together, these two guys right here. F prime of x is 2 sine x cosine x minus sine squared x plus cosine squared x. You can do that if you really want to. It's not, I mean, it may save you a little bit of time. It's okay to do that. That's fine. Plug in pi over 4. So it's f prime of pi over 4 now. That's 2 sine pi over 4 cosine pi over 4 minus sine squared pi over 4 plus cosine squared pi over 4. Alright, these do take a little bit of getting used to, so no worries here. But same process again. We have a point, find your derivative, plug that x value in, come up with your slope. So this whole thing is going to be, this is f prime of pi over 4 again. So I'm going to my unit circle. I'm going to look at pi over 4, which just happens to be right here. And I'm looking for mainly sines and cosines. Well, they all happen to be the same here, so that's lucky. They're all the same value. It's all the square root of 2 over 2. So this is going to be 2 times 2 over the square root of 2, 2 over the square root of 2, minus 2 over the square root of 2 squared, plus 2 over the square root of 2. Oh my goodness. I have had one kicker of a morning. You know it? I'm sitting here writing these things backwards. The square root of 2 over 2. Most of y'all probably saw that and were sitting there screaming at me. And well, I couldn't hear because it was a video. Oh, technology, you have failed me once again. You would not let me hear the cries and the screams of my people when they are trying to tell me, Mr. Ballard, no! No, it is not 2 over the square root of 2. You lark. It is the square root of 2 over 2. My apologies. Okay, so this is going to be square root of 2 times square root of 2 is what? 2, which is 2 times 2 is 4 over 2 times 2 is 4 minus, this will be the, actually, you know what? These are the same thing. If you want to simplify them, go ahead. It's 2 over 4 plus 2 over 4. I mean, they're the same thing, so they're going to go away. One's positive, one's negative. So, blah, blah, blah. It's 4 over 4, which is 1. The shock. So your tangent line, then, y minus your y value from the top equals your slope times x minus pi over 4. Shock and awe. Your normal line, y minus 1, equals, what is the opposite reciprocal of 1? Well, the reciprocal of 1 is 1, and the opposite of that is negative 1. X minus pi over 4. Yippee-ki-yay! I have never struggled so much doing a lesson in my life, and I have no idea why. Just trigonometry. That's okay, though. We've got it set up. When you get to class, we're going to do lots to practice on this one, and have a fantastic day.